Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 7, lesson number 6, practice problems. First question says, Priya says I can figure out 5 to the power of 0 by looking at other powers of 5. 5 cubed is 125, 5 squared is 25, 5 to the 1 is 5. What pattern do you notice? Well, 125 divided by 5 is 25. 25 divided by 5 is 5. So it's divided by 5 each time. If the pattern continues, what should be the value of 5 to the power of 0? Well, 5 divided by 5, because each time we're dividing by 5, is 1. How do we know? 5 divided by 5 is 1. If this pattern continues, what should be the value of 5 to the negative 1? Well, that's the next value, so it would be our previous value, which is 1, divided by 5. So it is 1/5. Select all the expressions that are equivalent to 4 to the power of negative 3. 4 to the power of negative 3 is 1 over 4 to the power of 3, which is 1 over 4 times 4 is 16. Times 4 is 64. Okay. So 1/64th. What is that equivalent to? It's not negative 12. 2 to the negative 6. Well, that would be 1 over 2 to the 6, which is 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So B works. C is 1 over 4 to the 3. That's one of the first little things that I said. So C works. 1 over 4 to the 3 is 1 over 4 times 4 times 4. So that means D works. 12 isn't even close. Negative 4 times negative 4 times negative 4 does not work. Ooh. 8 to the negative 1 over 2 squared. This is a tricky one. 8 to the negative 1 is 1 over 8 times 1 over 2 squared. 2 squared is 4. 8 times 4 is 32, so that doesn't quite work. Okay, what's next? Write each expression using a single exponent. Single exponent, if we have like bases and we are dividing, we subtract the exponents. So that is 5 to the power of 3, subtract 6 is negative 3. Which would be 1 over 5 to the power of 3. B is 14 to the power of 3 to the power of 6. When we are raising it to a power, we multiply the exponents. So that is 14 to the power of 3 times 6, which is 18. When we are multiplying 8 to the 3rd times 8 to the 6, we add the exponent, so that's 8 to the 3 plus 6 is 9. 16 to the 6 over 16 to the power of 3 is 16 to the power of, we're dividing, so we subtract the exponent. 6 subtract 3 is 3. 21 to the power of 3 to the power of negative 6. We are raising it to a power, so we multiply the exponents. 3 times negative 6 is negative 18. So that's 21 to the power of negative 18, or 1 over 21 to the power of 18. Okay. What have we got next? Andre sets up a rain gauge to measure rainfall in his backyard. On Tuesday, it rains off and on all day. He starts at 10 a.m. with an empty gauge when it starts to rain. 2 hours later, he checks, and the gauge has 2 centimeters of water in it. It starts raining even harder, and at 4, the rain stops. So Andre checks the rain gauge to find it has 10 centimeters of water in it. While checking it, he accidentally knocks the rain gauge over and spills most of the water, leaving only 3 centimeters of water in the rain gauge. When he checks it for the last time at 5 p.m., there is no change. So we have 2 graphs here. Which of the 2 graphs could represent this situation? Let me zoom out so we can see it all. He starts at 10 a.m. with an empty gauge. 10 a.m. empty gauge. 10 a.m. 4 in it. 2 hours later, he checks it and it has 2 centimeters of water in it. 2 centimeters of water, 2 centimeters of water. Starts raining even harder, and at 4 p.m. the rain stops. So raining harder, this got steeper, and at 4 p.m. the rain stops. Andre checks the rain gauge to find it has 10 centimeters of water. 10 centimeters, 10 centimeters. While checking it, he accidentally knocks the rain gauge over and spills most of the water, leaving 3 centimeters of water in it. So this instantly dropped down to 3 centimeters. This took time and went to 0. When he checks it for the last time, there's no change. So after he spilled some water, he checked it at 5 o'clock and it hadn't changed. Which of the 2 graphs? Graph A. Explain your reasoning. That's what I just talked about. Easiest explanation, it starts empty and graph A is the one that starts empty. Label the axes of the graph with appropriate units. So this is time, and it's by hour. Started at 10 o'clock, ended at 5 o'clock was the last time he checked it. Now, how about this? Now, the y-axis is rain in his rain gauge. And what is the unit? Centimeters. So y-axis is the rain in his rain gauge in centimeters. X-axis is the time in hours. 10 o'clock, 11 o'clock, 12 o'clock. Use the graph to determine how much total rain fell on Tuesday. Well, it started at 0, made it to 10, no more rain fell afterwards, even after he spilled it. So how much rain fell? 10 centimeters. It's our last one, right? Yep. Okay, that was our last question for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.